Hey guys, welcome to our second lesson in Programming with C. I'm Satyam Sharma, and joining me today in the chat is Mei Chen. Today we're going to be doing something a little differently than last week to see if your learning experience is enhanced. Mei is going to be monitoring the chat in Zoom room for questions, reactions, or comments, and I'll be teaching. That way you can ask a question at any time and get instant response and instant feedback. Today's lesson is not supposed to last longer than an hour, but we may or may not go a few minutes over and under. It just depends on how quickly the exercises will take. Don't rush, think carefully through them all, and don't peek at the answer unless you think you got it. Let's go to the homework questions. So, number one, explain how coding works. Use keywords like source code, compiler, linker, executable file in your description. Make sure you define each of these terms. Well, answers will obviously vary, but the main ideas that you should hit is that the source code is what we write, such as keywords, and it's everything in the editor that we see. The compiler converts it to binary, and the linker gets all the info necessary from the header files, such as a pound includes standard input and output. The executable file is what the computer can read, and it's the file that's about to be run. Number two, what framework should we have at the start of every program? What is the main function? Well, the answer to that is that at the beginning of every program, we should have that thing that I was just talking about earlier, pound include standard input and output header file. How that looks like is a hashtag sign, but we call it a pound in programming. Include, and then we have a less than sign, stdio dot h, then a greater than sign. What is the main function? The main function is the place where the main majority of your body of code lies. Even if you have more than one function, the functions are put here and they're actually run here within this body of code. So this is truly the main function. It's the place where everything takes place. In terms of notation, you have an int main, signifying that the function is an integer of an integer type. Then after main, you have open parenthesis, close parenthesis, and then you have a curly bracket. Then you have your entire body of code, and then you have a return 0. And we'll get into that in just a moment. Return 0 semicolon, and then we have a closed curly bracket. Now, diving into number 3, what are the two types of commenting? What is the difference between the two? Well, the first type of commenting is inline commenting. And how that works is you put two forward slashes that the slash between your the period and the shift bar on the right side of your computer. You put two forward slashes and then you type whatever comment, but the catch here is that you can't type outside of that one line. To deal with this problem, there's the second type of commenting called block commenting, where you have a forward slash and then you have an asterisk or a star, and then you have your block of code. Can be a paragraph, can be a book, can be just one line, but the length doesn't really matter, but it's all commented. You end the comment by putting an asterisk and then a slash. So you start it with a slash asterisk, you have your block of code, and then you end it with a asterisk slash. The storage box analogy in your own words. Well, just like you have storage boxes to hold your items and you label them, variables can be seen as virtual or computer storage boxes. The variable name is the label on the box. The expected material / size of the box is determined by the data type. What you store inside of the boxes is like what you'd assign to them. So it's pretty similar. See the previous PowerPoint for more information, or if you want a more in-depth explanation. Number 5, what are the 3 types of data types we discussed? Give an example value that can be stored in each data type. Well, the first one is char or char, and you just do a letter or a symbol, and you have single quotes. So you could do single quote A and then N single quote. Then the second type of data type is int or integer, and you type in a whole number. It can be negative, it can be 0, it can be positive, but no decimals, no fractions, just a whole number. And then the third actually does deal with decimals, and that's called the float data type. And an example of a float would be 0.2892 or 3.14, whatever really you want to do at that moment, but it needs to be a decimal. It can be 3.0 as well, if you want to get a little more precise. Number 6, what is the format specifier for char, float, and int? For character, it's %c. For float, it's %f. And for integer, it's %d. Straightforward. Either look it up or look at the last PowerPoint if you want to review that. We're going to be covering that a little bit again today. So the final one, assume you have the following variables declared and initialized earlier in the code, and then you have this whole host of 4 variables. Use one printf statement, write one printf statement that you would give an output of, that would give you an output of the mean of these 3 numbers is 7.4. And so this was kind of like your project. You would just do printf the mean of %d, %f, and %d is %f. And I'll actually cover this in the next slide when we go into the actual project details. So speaking of which, let's head over to an example of project 1. So again, here's an example of project 1. C is a very flexible language, so your code does not have to look exactly like this. It just needs to hit the key points outlined in the pseudocode. And in the pseudocode, we have 4 major steps, which we will be covering briefly or shortly. We have the header file for standard input over here, and that's that £include standard input and output header file. We have right below, we have the int main function, which is where all of our actual code lies. We have 4 variables, 2 integers, num1 and num2, 2 floats, num3 and mean, and we already have the variables assigned to numbers and decimals according to their data type. We initialized mean to 0 here and calculated it, but honestly, you could have skipped setting mean to 0 and just plugged this formula. You could have just set float mean equal to, and then put in this formula. That would have been just perfectly as fine, would have worked just as well. And then we have our favorite output function, printf, which uses the format specifiers, %d for integer and %f for floats. Finally, we end with you can't see it here, but there's a return 0 underneath this gray bar. And don't worry about what it does in essence yet. It just indicates that our program has been run successfully and we terminate our main function with this return statement. You will go through a whole lesson week on functions and you will cover this extremely extensively. So just keep the structure, this basic structure of, int main, variables, source code, et cetera, and then you have that return 0 at the end of the function. And you'll understand this a lot more in detail during the function week. So here's an output of the function. You have your 3 numbers predefined that you already declared. You have num1 is equal to 5, num2 equal to 3, num3 equal to 4.5. And then you take the mean of it, and it's pretty standard. Most of you guys did a pretty good job, and those of you who made some mistakes, they were really easily fixed. That was good. Let's go to the next slide. So pseudocode. Pseudocode is the process where you plan how to write your code. It happens before coding. It's written in comments, not the actual code. And everyone has their own processes. So don't worry if yours don't match exactly what ours is. So let's go back to this example of project 1. As you can see here, we have step 1. And what step 1 is the list of what you might need for your program. And we write it out in words. That's the key difference between pseudocode and real code. We write out what we want in words to make it easier for our brains and for us later as programmers to understand what's being said and what actually we're going to need and use so that we can use it as efficiently as possible. Step 2 is to list any variables or constants that you were planning to use and name them. I know you guys might not be familiar with what a constant is, and we're going to be covering that in this PowerPoint. But in this case, we had only variables, and we named num1. We named two of two integers, num1 and num2, and we had two floats, num3 and mean. And so this is the only part that's really code-like in the pseudocode. Generally, you use words. And then we have steps 3 and 4. And what step 3 is to plan out what functions you need and what they do. And step 4 is to take this thing take that and write it out the way that you would normally speak, as if you were explaining it to a toddler, rather than writing the actual code relating to that. So as you can see in this case, we had our objective pretty clear. We wanted to calculate the mean. We added the 3 numbers up, and then we divided the sum by 3. And that's just a subsection of calculating the mean. And then we said we wanted to store that into a mean variable. Again, you could have combined these two and just define the float mean as this set of operations here. But again, C is a very flexible language. You do you. Pseudocode is also very flexible. You do you. Just make sure that there's some organization and order to this. And to top it all off for the pseudocode, we just had the output. Really wasn't necessary, but gave us an idea of where the output would lie in the structure of the overall program. So let's go to an example, more examples of pseudocode. So we have here, we have step 1. We once again defined what we might need for our program, and we want, in this case, it seems we want a random number between 1 and 1,000, and we want the user's guess. And then step 2, we list any variables or constants that we might need, that we're planning to use, and name them. So same old, same old. Step 3 is to plan what functions you need and what they do. So we have 3 functions in this program. Each one, we broke it down into several parts, top-down level programming. And step 4 is to write out the steps in the way we would normally speak. If you notice, there's, other than the initialization of these variables, there is no single line of code here. And that's because we're not coding yet. We want to have a clear idea of where we're going, and then we're going to use the code to essentially match the pseudocode so that we can get a desired result. So that about wraps it up for pseudocode. It's very simple. Once again, it's not really code. It's just a way of getting clarity in your mind before you start. And right now, the programs that we're doing are very minor and basic, but soon you'll get to a point where you're writing hundreds and maybe thousands of lines of code. And for that, you really want to have a clear mind so that your code is as efficient and effective as possible. Let's get into binary. So the binary numeral system is a way to write 2 numbers using only 2 digits, 0 and 1. These are used in computers and are what drives the heart of the program. They're used in computers as a series of off and on switches, and in binary, each digit place is twice as much as the value of the next digit to the left of it. And so we discussed this more here. But first, why do we even use binary? Why not just stick with our usual 1 through 10 or 0 through 9 counting? Well, the thing is, computers aren't humans. And although they're getting more intelligent every day and every year, they're still inanimate objects at this point, or they're not understanding decimal notation. And that's because they respond to electrical pulses from current flowing and not flowing. They get information based on whether current is flowing at a particular instance or not flowing at a particular instance. And so you have this idea that if a current is flowing, you have a quote unquote on, and that corresponds with a 1. And if you have an off, that corresponds with a 0. And actually, there are a lot of codes that people use that actually utilize binary in order, and so they can pass information discreetly, encryptedly. So let's do some exercises and examples relating to binary to get more of an intuition about what binary is. Each time you move to the left, the decimal equivalent of the place value doubles. What does that mean? Well, let's take this example. 1, 1, 1, 1, 1, 1, 1, 1. 7 ones. Well, we start off with the decimal equivalent of just this over here is we start off with a 1. Then we double that when we go to the left. So this is 2. Then we double that to get 4, double that to get 8, 16, 32, 64, and so on. Then what we do is we take whatever decimal values here, so 1 here, over here it would be 16, or sorry, 8 over here it would be 16, and you multiply it by whether it's a 1 and 0 in this place. So coincidentally, all of them are 1s, so what we do is we multiply each number here with 1, and we sum them all up to get the decimal equivalent. And remember, decimal is just our regular counting numbers. So if you, 1 times 1 is plus, since this is 2, 2 times 1 plus 4 times 1, since you double it, plus 8 times 1, plus 16 times 1, plus 32 times 1, plus 64 times 1. We add it all up and we get that 1 in binary is the equivalent of 127 in decimal. Another example of this that kind of gets you an intuition is that 1010 in binary is just 1 times 0 plus 2 times 1 plus 4 times 0 plus 8 times 1. Now, how do we get that? We start off with 1 once again here. We double it to get 2, double it to get 4, we double it to get 8. We take those decimal values and we multiply it with whatever binary value there is. So we have a 0 here, and the decimal equivalent is a 1, so we do 1 times 0. And then remember, we double it, so we get 2. We have a 2 times 1, and then we have a 4 times 0, and then an 8 times 1. Sum it all up, and we get 10 in decimal. This isn't as important when you start off programming, but soon, since C is such a computer-oriented programming language, meaning that it talks to the hardware, you're gonna need to get familiar with binary slowly but surely. And so this is kind of a starting point to get familiar with it. So let's do a quick exercise. What's 1101 in binary? What's 1101 in binary? What is the equivalent of that in decimal notation? So I'll give you guys around 5 minutes, and then if you're done with that, write your name in binary and type this up in the chat, and we'll go over this in about 3 minutes.
Yeah.
One more minute. All right, finish up that last thought or last attempt, and if you haven't already, move on to writing your name in binary. Once again, once you're done with that, enter it in the chat. I'll give you an extra 1 or 2 minutes. All right. So we're gonna go to the answer and the solution. Keep on trying. If you want, uh, if you want to practice more, do the homework this week, and there will be more binary related problems. It takes time to get used to it, to get a handle on it. So don't feel bad if you didn't get it in 5 minutes, but um, yeah. So we're gonna move on, so because we have a lot to cover right now. So to answer the I can't tell you everyone's name in binary because that would take too long. But for this example over here, let's go to the answer over here. So we have our number in binary written here, and we have the value of the placeholder beneath it. And so what we do is we take the binary value here, multiply it by the value of the placeholder, and sum it across all of these numbers. So once again, you do 1 times 1 plus 0 times 2 plus 1 times 4 plus 1 times 8. And summing it all up, you get 13, which is what I think most people in the chat got. So great job on that. Kudos to you guys. Um, Now let's move on to constants. So this is another major topic in C programming, and you're definitely going to want to need this when you get more and more advanced. Even as you graduate out of C, go into other languages, constants are a critical part of your programming experience. So unlike variables, constants do not change. The values in the variables can be different every time, which is why you use constants when you want the data to stay the same. Declare the constant. These are just some rules. So declare the constant before the main function and assign it the value you want. You can use the constant in different functions, unlike variables. So um, as we get more and more into our discussion of functions, you can use a local variable in one function, but it won't be universal, meaning that if you define a variable in one certain function, it won't be present, it won't be defined in another function. But constants, since you define them outside of all the functions, you'll uh, be able to manipulate them across all the different functions, different uh, pr- things that you do across the entire course of the program and across your source code. Do not yet declare variables this way. We'll get into what's called global variables later. There's some pros and cons of declaring variables this way. And sometimes the cons outweigh the pros, sometimes the pros outweigh the cons. It really just depends on the situation. And so we'll get into that in a later week. And take some time to look over this infographic, guys. It's about constants versus variables in C programming. It's a little more technical than what I just described here. So if you know this stuff that I described here, you'll be fine. But take a look at this and try to take a crack at understanding this. I'll give you a minute or two. It's this is this is pretty important stuff. So. All right, so let's move on from constants to constants and variables to another topic. But before we do that, let's go into an example. So here's an example of what we talked about on the previous slide. Notice this line right here. It may be unfamiliar to most of you, and this is how to formally declare a constant. This is the syntax needed to declare a constant. Notice how you don't declare this constant underneath the int main or within the body of the function. You declare it right underneath the standard input output header, and that's critical because that allows the this pound define to be a universal constant. We call the formal way to say this, as I've been saying, is pound define. You don't say hashtag define, you say pound define. And we say we make usually the syntax or the way to declare a constant is to make sure it's in all caps because that's just the notation. And so when you go and interact with other programmers, this is the notation that they use. It technically will work if you don't use all caps, but it's just better to get in the habit of doing it since everybody else is, and it's going to be easier for everyone else to understand. It also helps differentiate it from variables. Um, the number, it's really important to stress that the number will stay the same throughout all functions, all lines of code. It cannot be altered, and that's why it's by definition a constant. So another key thing here is strings and character arrays. We're going to get into this a lot more in detail um, over the course of the next couple of weeks. But to introduce it, a string is just a sequence of characters that is treated as a single data item and terminated by the null character, and we call it \0 as well as the null character. Either or works. Remember that the C language does not support strings as a data type. This is important. A string is actually a one-dimensional array of characters in the C language. Now, what is an array? Well, an array, put quite simply, which again we're going to be expanding on this in later weeks, but an array is just um, a set of various individual elements put together in these curly brackets, and that makes an array. So this right here, the second black line over here, that is an example of a character array. And why is it called a character array? Well, it's an array and it only contains characters, and you know that because there's single quotes everywhere. You cannot put a double quote in here unless you do it for all of them. So make sure to be consistent with whatever you do. And in some places, you can't even put a double quote. It just depends on the integrated environment that you're using. Uh, a string, um, a string is used to a string and a character array is often used to create meaningful and readable programs. And this way, defining it like this allows you to manipulate it. Defining it like this is kind of like keeping it constant, meaning you can manipulate it, but it's a lot harder to. So you generally, if you write it like this, you tend not to. Let's take an example. So the string hello world, notice the space, can be written like this with quotes, or like this character array with a single quote A, single quote E, and make sure to have that single quote space when you declare that character array. And then, very important, it's terminated with the null character, the \0, and that lets the compiler at the know that you've reached the end of the string when it's compiling the program initially. So take a look at these examples here. Take some time to do it to really immerse yourself or to really understand what's going on here. You have a character. That's that's the symbol for character, and then you have the variable name, or the array name in this case. So you have the character, and we called it name, and then we have these square brackets, and that specifies how many elements is the max capacity. Generally, we tend to put more elements than there actually are. The reason for that is so that if you overestimate, the computer allows you to have more memory for that one specific variable than you need, so you can fit, let's say you later on in the program you add something to the character array. You're easily able to do that, whereas if you put it exactly at, how many is this, 8, if this was char name 8, you wouldn't be able to expand it without having to create an entirely new character array, because then the memory wouldn't be able to be allocated correctly. Remember that when you initialize a character array, by listing all of its elements separately, then you must supply the null characters explicitly. And it's just exactly what I said here, but it's a very important concept. And many great programmers have had their programs constantly get errors because they forgot to do this. So it's just a good habit to get into doing that now. An example of an illegal initialization of a character array is char name 5 hello. And can you type in the chat why exactly this is an illegal initialization? Go ahead, and I'll give you a minute to try to figure it out. Type why you think it's an illegal initialization. Okay, so that's time. So I saw a lot of interesting things in the chat. So let me just address some of the common things that people said. And we've actually done this class before with a separate group of students as well, and they said very similar things. So I just wanted to clarify this. So uh, after someone said after every word there has to be a quote. So that's actually a very smart approach of looking at it. However, the reason it's incorrect is because these quotes actually specify that it's a character. So if you were to break this down into a character array, what this would look like is single quote H, single quote E, single quote L, single quote L, single quote O, just like it's up here. And if you notice up here, it's just 5 characters long, which matches this, except here's the thing that's missing, this null character. If it needs to be a 6, it needs to be 6 or greater. Uh, there need to be 6 or greater specified here in this initialization of the character array. So that's why it's an illegal initialization, because you're trying to fit 6 things into a spot where there's only 5 slots available, and the computer doesn't like that, so it will probably send you an error message. So it was a tricky one. Hope that was a illustrative example. Now let's get into scanf. Scanf is a pretty important function. You use the standard input-output function once again, because this is a way of collecting input from the user. So take a second to refresh your memory about the format specifiers while I'm talking, because this is what you're going to use to get the variable, to get the user's input and assign it to a variable. So we have, if you look at the syntax of this function here, you have 2 arguments. And what the first argument is a quote, and then you specify the format specifier. So whether it's %d for integer, %f for float, whatever, you put it between these double quotes, and that's imperative that they're double quotes, and it's imperative that you put the format specifier within the quotes. Then you have a comma separating the 2 arguments, and then you have this ampersand. Most of you know it as the fancy and symbol, but it's called an ampersand more formally. And what the ampersand is, it defines the address of the variable, stores the data in that variable. You would have to declare the variable first prior to using this function in order for it to be stored, because you can't just use a variable that doesn't exist, because the computer wouldn't know that that's a thing. Quick formatting tip, scanf puts a new line in the output. It's very useful, and it's kind of annoying when you have to put \n after every line to get a new line. So it's really nice that scanf actually just lets you put a new line in the output. Let's take a look at an example with this. So here you have that standard library. You need this library to use functions like scanf and printf. Again, this stdio.h stands for the standard input output header file. Standard input output header file. That's a very important library. It's probably the most important library and the most basic library that you can have and understand. Then you have this #define include. So that tells you to include the standard input output header file. Once again, you have the int main, you have the first starting curly braces. You declare this variable because, as I said on the previous slide here, you need to, in order to use this ampersand and to collect the input from the user, you want to declare the variable prior to using this. So we declare the variable here, int cats. Then we ask, how many cats do you have, to the user? The user types something in, and in this next slide, you see that they type in 5. So you're prompted, how many cats do you have? You type in 5. And then when you go back, you see that you use scanf to collect the integer. You use the integer format specifier. You collect the integer of the number of cats that this person has. And then using the ampersand and then the variable name, it takes the user inputs and stores it into the variable, which in this case is cats. And then the fun part about that is that now cats, even though it wasn't explicitly defined to be 5 in this case, even though it wasn't explicitly defined to be 5, you can still use it without ever specifying the number explicitly. So for example, in this next line, you have printf, you have format specifier for integer cats, and you can use the comma variable name strategy that you discussed last week to actually say how many cats the user has. And of course, this is kind of dumb because we just asked them how many cats you have, and then we told them how many cats you have. It was just for the sake of an example. But the point is that you can collect user input now, which is a very powerful thing to do. And you can use that user input and manipulate it. You could have written cats plus one instead of cats, and that would have put 6 cats. You can all the things that you can do with a regular variable, you can do with the user variable, which is a bit insanely powerful thing to do, and it's the basis of many client programs across the web. So it's very important to understand that concept. Now, escape characters. So this is straightforward. You guys learned this a little bit last week. I'll just review it again and teach you. And if you don't remember, this is great first time learning. Make sure to use the backslash first and foremost. There is a forward slash that is right between the shift and the greater than sign. You don't want to use that. You want to use the backslash, which is underneath the backspace. And then you type in one of the following. And of course, there's more, but these are the basic ones. So you do backslash T for tab. So let's say you want to tab some text without actually having to press space 5 times. You do backslash T. And you can do it as many times as you want. You can do backslash T 10 times, and it will tab it 10 times, essentially. You can do backslash B. That's a backspace. Just like it implies, it moves the cursor backward. You can do a backslash double quote or a backslash single quote. And what that does is it allows you, let's say, take an example over here. Let me go back over here. So over here, you had a printf, and then you had a double quote, and then you had some prompt or some message, and then you had a double quote. But let's say you're, I don't know, telling a story or whatever, and you, for some reason, need a double quote within this text. Well, the way to problem solve around that is that you use this backslash double quote so that you show the double quote within the string, and it doesn't make it seem as if it's ending the actual string then and there. Because to clarify, what would happen is, let's say you said, I don't know, Dora said, comma, and then quote. Well, that would just make it so that you would only print Dora said. But if you wanted to print Dora said, find the map, you would say, quote, Dora said, comma, backslash double quote, find the map, and then you would end the quote. And, or you could use another double slash, backslash double quote if you wanted. Same thing, I know some people prefer to use print statements with single quotes. Just a matter of preference, like I've been saying all along. C is a very flexible language. You can personalize it to your own tastes and preferences. So yeah. Then this one is pretty familiar. Backslash n creates a new line. Usually put it at the front or the ending of a print statement or a scan statement, or not a scan statement, a print statement, or other output statements. But yeah, it's you guys are pretty more familiar with this one. I just wanted to emphasize these 4 because they're not as common as the new line. So that's it for this week. Great job. You guys were a wonderful audience today. Here's some key things. Where to access the homework / turn in assignments. I know somebody in the chat was asking about where to find the slides, and I see some people are also viewing this, viewing the slides. Go to chicandcode.net and hover over the C tab and click the 8-week course. And you can access all content on this page. We update it weekly, sometimes even every couple days. If you email us and you have any specific questions, you can, or you for some reason can't access the homework, feel free to email us and we'll be sending it to you. All lessons, this lesson is recorded and it's going to be found there. Homework is found there. Make a copy of the homework document and submit it through the page. If you guys did this last week, great job. If you didn't, try to do it this week. No harm, no foul. It's a learning experience. You definitely need a REPL.it account. And that's because it's really easy to share. We're going to be moving off of REPL.it sooner or later, but REPL.it is a great web-based integrated development environment, and You can program in any language there. You can share code over email, you can put it on GitHub if you guys know how to use that. You can turn it into as a homework assignment. So it's a very flexible environment. So I highly recommend it, especially if you're starting out. And you definitely need one to send the homework in. So additional help can be found on this website or any of these two emails. So whoops. So that's it for this week. Thank you. Hope you guys stay safe. If you guys have any questions, we'll be here for another 5 or 10 minutes. So just type whatever questions you have in the chat. Yeah, that's it. Stay safe. Practice good social distancing. And yeah, we'll be here for the next 5 minutes if you have any questions. See you.